Chapter 9, Lesson 1, Scatterplots. You will be able to construct and make conjectures about scatterplots. Data with two variables, or pairs of numerical observations, are called bivariate data. A scatterplot shows the relationship between bivariate data graphed as ordered pairs on a coordinate plane. For example, the bivariate data set year and number of visitors can be displayed as a scatterplot. Construct scatterplots for the following. Construct a scatterplot of the number of viewers who watched new seasons of a certain television show. Okay, so our x-axis here would be our season, and our y-axis would be our viewers. So let's just jot that in. And let's note that our viewers is in millions. Okay. Now we are just going to be plotting points. Season 1 is 31.7 million viewers. So Season 1 is 31.7. Season 2 is 26.3. Season 3 is 25 even. Season 4 is 24.7. Season 5 is 22.6. Season 6, 22.1. Okay. And that's all there is to a scatter plot. It's basically just plotting some points, and they're scattered. They don't have a clear straight line or any sort of parabola. They look like they're in a straight line. It looks like it's decreasing, but they're scattered. Letter B. Construct a scatter plot of the weight of an alligator at various times after hatching. Okay, so our x-axis here is our weeks. And our y-axis is our weight in pounds. Okay, and let's go ahead and plot. 0, 6, 9, 8.6, 18 is 10, 27 is 13.6, 34 is 15, 43 is 17.2, and 49 is 19.8. So again, here's our scatter plot. This one looks more like a straight line than our previous example, but it's not perfectly aligned, and it's a scatter plot. Now let's talk about interpreting scatter plots. You can analyze the shape of the distribution of a scatter plot to investigate patterns of association. If the distribution shows a positive or negative association, then the distribution can be classified as linear or nonlinear. So here we go. We've got points that are increasing. So as x values increase, your y values increase. Therefore, we call this a positive association. Similarly, as x values increase, your y values decrease. We would say this is a negative association. And in this last example, those plots are all over the place and there is no obvious pattern, so we say that to have no association. Linear is when the points appear to be in a line. Nonlinear is when they don't appear to be in a line. Okay? They're more of a curvy shape than a linear shape. And this scatter plot here shows a positive nonlinear association because it looks like they curve. Okay? There are clusters and an outlier. The clusters, right here, there's a bunch of points that appear together, so we would call that a cluster. And then there's this point way over here, nowhere near the other data, we would call that an outlier. So interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. So the first thing you're going to say is whether or not each axis is increasing or decreasing. So start with your x-axis. As memory increases, and what happens to the cost? As our memory increases, it looks like our cost, it starts down here in the 30 range all the way to the 200 range. So I would say as memory increases, cost increases. Because of this, we're going to call this a positive association. They're both increasing, therefore it's a positive association. Okay. Does it appear to be in a line? Well, it doesn't look like it's curved anywhere. It does look like it goes in a line. So I would say yes, the data appear to lie on a line. Therefore, we can say linear association. And it looks like, as far as clusters, I have a cluster here, and I don't see a cluster really anywhere else. So I would say cluster between $30 and $75, and I'm getting those values from my cost. So $30 all the way up to $75, there seems to be a cluster. And I do not see any data out there, so I'm going to say no outliers. Interpret the scatter plot of the data for the time elapsed and temperature of water based on the shape of the distribution. Okay. So we can say as time increases, what happens to our temperature here? Well, it looks like temperature decreases. Because of this, we can say it's a negative association. And again, our data appear to form a straight line, so we can say that the data appear to lie on a line. Therefore, we would call this a linear association. Here I don't see any clusters, and I also don't see any outliers. Interpret a scatter plot of the data. Let the horizontal axis represent the year since 1999, and the vertical axis represent the number of students enrolled in public schools. Make conjecture about the number of students that will be enrolled in public schools in the year 2015. Okay, so let's interpret our data first. As years increase, the number of students, it looks like they also are increasing. Therefore, we call this a positive association. And the data appear to lie on a line. Therefore, linear association. I don't see any clusters, and I don't see any outliers. Now we have to try and find the pattern of our graph here. So if I were to imagine a line, let me go ahead and draw one for you. So if I were to imagine a line and following this data, I would say that would be pretty close to the data, maybe even moving it up a little bit. So if I look at 2015, now keep in mind that 2015, or that this starts at 99. So this is 1999, 2000, 2001, 2002, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 2015 is at my year 16 mark. Okay, let me just adjust this line. So at the year 16, follow this data point all the way across, there appears to be about 51 million students enrolled in public schools. So that is our conjecture. So in 2015, there will be about 51 million students enrolled in public schools. Interpret the scatter plot shown for the men's Olympic 100-meter freestyle swim winning times. If an association exists, make a conjecture about the winning time in the 2016 Olympics. Okay, so as years increase, the winning time decreases, and we call this a negative association. The data appear to lie on a line. Therefore, I would also say this is, again, a linear association. I don't see any clusters. I don't see any outliers. So it looks like these count by 8 years, skipping one, so really 4 years. So this is 2000, 2004, 2008, 2012, 2016 will be here. So this is 2016. So let's kind of draw that imaginary line again and see where it'll fall. And I'm going to have to adjust my line as we go here. Okay. So in 2016, I would say it's about 45 seconds. So the winning time in 2016 will be about 45 seconds.